Okay, so we can start in the last lecture we stopped here. Actually, we started to go through the hydrocarbon chapter is almost going to finish here in this lecture, today's lecture. So we have discussed about the electrophilic substitution reaction with the benzene ring like nitrogen. Nitrogen we can do with the different kind of mixture acid like HNO3 and H2 super mixture, and then chlorination halogenation also we can do in the presence of the chlorine, and the in the presence of anhydrous LCl3 in the, and also FeCl3 FeBr3 or AlCl3 to yield the haloarenes moiety. Even if you add the if you increase the equivalent of the mix acid, that is the HNO3 plus H2 super, then you can get the that is the mono one, that is the monodentate nitration product, mono substituted nitration product. This is nitrobenzene, as well as the di substituted also you can get, whether it will be the meta substituted, whether it will be the para substituted, or so there is three possibility. So one nitration can happen to the benzene ring. So one is the nitrobenzene here. Okay. Then the other one is will be the orthobenzene, orthonitrobenzene. Okay. And the third one will be the orthonitrobenzene. This is the orthonitrobenzene. Orthonitrobenzene. And then another one will be the mononitrobenzene, metanitrobenzene, metadinitrobenzene, and then it will be the paradinitrobenzene. It will be the paradinitrobenzene. Okay, so there are four possibilities. One is the nitrobenzene, then is the orthodinitrobenzene, then the metadinitrobenzene, and the paradinitrobenzene. Okay, now we'll go to the not disubstituted. It can again undergo the trinitration, that is the TNT, trinitrotoluene, trinitrobenzene, not toluene, that is the TNB, trinitrobenzene. So TNT, then how will you get the TNT, trinitrotoluene? So if you start from the benzene, if you start from the toluene, so then if you start from toluene like CH3 here, then if you do the nitration, that is HNO3 and H2SO4. HNO3 and H2SO4. HNO3 and H2SO4. Then what you will get? Trinitrobenzene. Trinitrotoluene. This is trinitrotoluene. Trinitrotoluene. That is also one of the explosive reagent. Trinitrotoluene. TNT. That is called TNT. Okay. Now we'll go to the sulfonation reaction. The sulfonation reaction also we have discussed. So when you use the benzene with H2SO4, then there will be the monosulfonation. Not over sulfonation can happen here. That is for the nitration only, over nitration can happen. But a Friedel-Crafts reaction is what? So if you use this kind of C2H5Cl, C2H5Cl is what? CH3, then CH2, then Cl, then anhydrous LCl3. Then what you will get? You will get the ethyl benzene, CH2 and CH3. CH2 and CH3. This is called ethyl benzene. Okay. Now this is called the ethyl benzene. Now we'll go the Friedel-Crafts alkylation also done with when we are using the alkyl halide So then the acylation. Acylation means what? Acyl group transfer to the benzene ring. So acyl group means COCH3. Acyl group means CO then CH3 with any other aromatic group present here. Aromatic group present here. This is called acyl group. This is called acyl group. This is called acyl group. So what it is going, what it is doing? So actually it is doing what? Acyl chloride. So the reaction of benzene with an acyl halide or acetic anhydride in the presence of Lewis acid like AlCl3 yields yields the acyl benzene. So what is acyl benzene? That is benzene with COCH3. So benzene with COCH3, that is the acyl benzene. Now instead of this acetyl chloride, again someone can use also acetic anhydride. So acetic anhydride is what? Acetic anhydride, when you are using the benzene ring with the acetic anhydride. Acetic anhydride structure is looks like the CH3 CO O CO CH3. So let me draw this structure. So CH3 CH3 CO, then O, then CO CH3, CO and CH3, CH3 CO, O, CO, CH3. Okay, so this is the main scenario. Then also the byproduct will be the acetic acid, CH3 COO8. Now to lecture is the lecture 10, where I will conclude this one with very short in time. So if we use the excess of the electrophilic reagent, then further substitution reaction may take place, but in which other hydrogen atom of benzene ring may also be successfully replaced by the electrophile. And for example, benzene on treatment with excess of chlorine in the presence of anhydrous AlCl3 can be chlorinated to the hexachlorobenzene. Okay, so this is the hexachlorobenzene C6Cl6. So if you use the benzene ring with 6 chlorine atom, then what you are getting? So you are getting the, let's say if you start from the benzene ring, if you start from the benzene ring is look like in this way, then you use the 6Cl2. Okay, because if you want to use the chlorination in the only one position, then one chlorine atom is sufficient. The Cl2 is the sufficient, chlorine molecule is the sufficient for the monochlorination. But if you want to do the further substitution reaction, even if you want to replace all the hydrogen atom, because here total 6 hydrogen hydrogen is present here. So now let's say this is a hydrogen, this is hydrogen, and this is also hydrogen, and this is also another hydrogen, and this is another hydrogen, and here also another hydrogen is also there. Now let's say if you use this one and anhydrous AlCl3, anhydrous AlCl3, anhydrous AlCl3, then what you will get? You will get the then you will get the 6 chlorine atom here. Okay, so this is the hexachlorobenzene. So this is the hexachlorobenzene. Now mechanism of the electrophilic substitution reaction. Now we'll go to the mechanism of this reaction. So if you see the according to electrophilic experimental evidence, substitution reaction, that is SE. S equals to substrate, where E equals to electrophilic. That is a denotation. Denoted, we can denote the substitution reaction as a S or E equals to electrophile. The reactions are supposed to be proceed via the following 3 steps. So one is the generation of the electrophile, then the formation of the carbocation intermediate, then the removal of the proton from the carbocation intermediate. So first generation of the electrophile. So electrophile during the chlorination, alkylation or acylation of benzene anhydrous, being a Lewis acid, helps in the generation of the electrophile. So what kind of electrophile they are using? So let's say, so any kind of, whether it is a halogenation, whether it is a alkylation, acylation or Friedel club alkylation. So wherever you can see the substitution reaction, all the reaction going through a carbocation intermediate, electrophile intermediate. So what are the electrophile can be happen? For the chlorination reaction, if you see the chlorination reaction, for the chlorination reaction, so chlorination reaction, for the chlorination reaction, so the electrophile will be Cl plus chlorination reaction. Okay, then the alkylation reaction. Alkylation reaction is the R plus. Acylation reaction is the, if you see the acylation reaction, is the RCO plus. Okay, these are the electrophile we can use in the alkylation, acylation, halogenation reaction. Halogenation is the specifically the chlorination reaction, Cl plus. So if you see the mechanism, now the concept is the we need actually Lewis acid. What are the Lewis acid people are using for this kind of chlorination, alkylation, acylation reaction of benzene? So people are using anhydrous LCl3. So anhydrous LCl3, why anhydrous? Anhydrous means the hydration, means the water will be not there in your condition. So water should not be there. Okay. Now the question is anhydrous. Okay. If it is an anhydrous molecule, then if it is anhydrous, then what will be the mechanism? So mechanism will be, so let's say if you start from the Cl2. So suppose we discuss about the Cl2 chlorination reaction. So Cl2 means what? Cl2. So if you have a Cl2 exists in this form, Cl single bond Cl. Now this Cl2 plus AlCl3 you have. So we know that the chlorine has the lone pair of electron, right? AlCl3. Now chlorine has the, now this Cl plus AlCl4 minus. Now this is a chloronium ion. This is a chloronium ion. Okay, so this is a chloronium ion. Now this chloronium ion and CH3Cl. So this is, let's say, chlorination reaction. Now this Cl plus and you have a benzene ring. Suppose now you have a benzene ring plus Cl plus. Now let's say this double bond. We know the nucleophile. This is the electrophile. Will go and attack here. Now what you are generating? You are generating a carbocation to the benzene ring. We know that the benzene also aromatic carbon, right? Now this is a positively charged. Now if it is true, now this double bond also can come to here. Then this double bond also can come here. You have a chlorine already here. Chlorine also already here. Now in this way, then again hydrogen here, one proton is there. Now there will be the minus of H plus, because you have a Cl minus negative charge, it is here. Now the Cl minus will take this proton and there will be a minus of H plus. So minus of H plus, this is a chlorobenzene. Okay. Now the chlorination reaction can happen here. Now the question is about the alkylation reaction. So if you think about the alkylation reaction, so in the chlorination reaction we use the Cl2. In the alkylation reaction, what we use? We use the CH3Cl. That is this one, CH3Cl. CH3Cl plus AlCl3 and AlCl for minus. AlCl for minus. Now this CH3 plus and benzene ring. Okay. So now you have a benzene ring because it is already written, but it is not properly explained. So that's why I am writing the mechanism part. So you have a benzene ring here. Now this benzene plus CH3 plus. Now this benzene, because in your in textbook only it is written how the mechanism is go. It is the proper mechanism they have not shown here. So you have only CH3Cl and AlCl3. They are showing the only the CH3 plus is generating, but how the product is forming they are not showing here. So this is the way the benzene can go, and the one of the double bond will go and attack to the CH3 plus. Now what you will get? So you will get the same kind of carbocation intermediate here also. So in the alkylation product, the if you are getting this kind of intermediate, then CH3 is here and you have a one positive charge. Okay. So in the same way, the above mechanism how it is done. So now you have, it will go by the three resonating structure intermediate, then minus of H plus, then what you will get? You will get the toluene structure. Toluene. You will get the toluene molecule. So toluene is what? This is the CH3 and benzene ring here. This is a CH3 molecule. It is present is here. This is a toluene. Now the same way it is also here also it is written in your textbook that when you are using the, so if you start from benzene to toluene, you have to use the this methyl chloride and AlCl3 for the Friedel-Crafts alkylation reaction. And in case of, so if you start from CH3COCl, that is acetyl chloride, that is called the acetyl chloride. Acetyl chloride. Now this acetyl chloride is a source of the CH3CO plus carbocation intermediate, that is called the electrophile. So this electrophile again react with this kind of benzene ring. In the same way mechanism will go, and then what you are getting, you will get the this COCH3 benzene ring. This is the the drawing is not properly, you can understand it is the COCH3. So this is called Friedel-Crafts alkylation, acylation. Okay, so the thing is that so I already discussed these things. So maybe I'll just go quickly here. Okay, so actually the thing is that, so we have discussed the chlorination reaction with AlCl3, or that is then that time we are getting the chlorobenzene. So you can see the mechanism. This is the mechanism where the first chlorine cation is generating, then the benzene will come and attack to the Cl plus ion, Cl plus carbocation. Then this kind of intermediate, it will go via three structure, 1, 1, 2 and 3. Okay, so we know that the the alkylation or halogenation or chlorination or like acylation, it always goes through a three stages. So one is the generation of the electrophile, and the second one is the formation of the carbocation intermediate, and third one is the removal of proton from the carbocation intermediate. So these three steps we'll discuss here. Although all the steps is not discussed in your textbook, but I'll discuss it in this lecture. So what will happen? So let's say for the example, if you start from the chlorination reaction, so in the chlorination reaction you are using the Cl2, and in the presence of AlCl3, what you are getting? So in the presence of Cl2 and AlCl3, you are generating the Cl2 Cl plus. This is the Cl plus. This is the electrophile. Now Cl plus plus AlCl4 minus. This is the another negative intermediate, carbon ion moiety. Now this chloronium ion, so this is called the chloronium ion, carbocation. Now this chloronium carbocation you have, and you need a nucleophile. So nucleophile is coming from your benzene ring. So if you start from a benzene ring, here it is. Now you have a Cl plus. Now this Cl plus and benzene will go and react, will give the this kind of carbocation moiety. Now this carbocation with Cl the three structure, one is this kind of double bond will come here to stabilize this carbocation moiety. Then again there is a generation of this carbon as a positively charged. Now this carbon also can be stabilized through this double bond. So then again there will be a generation of this positive charge here. Now you know that in the chlorine is attached to that carbon, that which carbon, that carbon one proton is already exist. So this proton will takes up by the chlorine minus ion. Now this chlorine minus and hydrogen will extract, then it will generate the HCl plus chlorobenzene moiety. Now, not only this chlorobenzene. So now the question comes, not the chlorobenzene. If you're talking about the alkylation, Friedel Crafts alkylation, so from the Friedel Crafts alkylation, you have to start from the alkyl halide. Now, what are the alkyl halide is there? So alkyl halide means, so there is a alkyl halide means the CH3Cl. Let's say from the very small family of this alkyl halide is the CH3Cl. So CH3 is the only one carbon. So CH3Cl. If you start from the CH3Cl and AlCl3, so then what you are getting? So you are getting AlCl3 plus CH3Cl. So you are getting CH3 plus and AlCl4 minus. Now this is a carbon ion moiety. Now this CH3Cl and plus AlCl3 and CH3 plus. Now this CH3 plus benzene ring, it will go and